Hey everyone, and welcome back to day 3 of our 100-day computer science journey. Yesterday, we took a fascinating dive into the core components that make up a computer system, understanding its internal anatomy. Today, we're shifting our focus to an equally crucial aspect: how you, the user, actually interact with that powerful system. We're talking about input and output devices. Think about it: how do you tell your computer what to do? And once it's done its job, how does it communicate the results back to you? That's the fundamental two-way street we'll explore in depth during this essential 5-minute lesson. Let's kick things off with input. Input devices are exactly what their name implies. They are the tools and mechanisms you use to feed information, data, and commands into the computer system. Imagine you're typing a document, crafting an email, or even just searching for something online. What are your primary tools? Your keyboard, of course. Every key press sends a specific signal, a piece of input, to the computer. Similarly, when you navigate your cursor around the screen or click on an icon, your mouse is constantly sending input about movement and selections. But it's not just about typing and clicking. If you're recording a voice message or chatting with friends via video, your microphone is diligently taking your analog voice, a sound wave, converting it into digital data, and transmitting it as input. Scanners capture physical images or documents and turn them into digital files, and webcams capture live video streams. These are all vital gateways for us to pour our intentions, data, and commands into the digital brain of the computer. Now, what happens after the computer processes all that input? It needs a way to show you the fruits of its labor, right? That's where output devices shine. These are the components responsible for presenting processed information from the computer back to you, the user. The most ubiquitous example is the monitor or screen you're using to watch this very video. It interprets the computer's complex digital signals and transforms them into visual information, text, images, videos, that you can easily understand. When you need a physical copy of a report, your printer takes that digital file and outputs a tangible, hard copy. And if you're enjoying music, listening to a podcast, or hearing game sounds, your speakers are taking digital audio data and outputting them as audible sound waves. Other examples include headphones for private listening, projectors for large displays, and even vibration motors in game controllers. All these devices serve as the computer's voice and vision, communicating its computations and results back to us in a comprehensible format. The beauty of input and output devices lies in their harmonious, continuous collaboration. Think of it like a seamless conversation. You speak a command, input via microphone, the computer processes what you've said, perhaps accessing its memory, and then it replies, output via speakers. Or you type a complex question into a search engine, input via keyboard. The computer diligently finds and organizes the answers, and then displays them clearly on your screen, output via monitor. It's a constant, dynamic cycle: input, processing, output, repeat. Without these essential devices, a computer, no matter how powerful its internal processor, would be a brilliant brain trapped in a silent, dark box. It would be utterly unable to communicate with the outside world, and critically, we wouldn't be able to give it instructions or receive the valuable computations it performs. They are, quite literally, the indispensable bridges between the human and the machine. To cement this concept, let's use some simple real-world analogies. Imagine a modern vending machine. Pressing buttons to select your desired snack is a clear form of input. The machine then processing your choice, dropping the snack, and displaying the price or change due is its output. Or consider a sophisticated traffic light system. Sensors detecting the presence of cars at an intersection could be seen as input. The changing of the lights, allowing or stopping traffic, represents the output. While our computers are infinitely more complex and versatile, the fundamental principle of receiving instructions and delivering results remains consistently the same. So, to quickly recap the crucial takeaways from today's lesson, input devices are your essential tools for sending data, commands, and information to the computer, with examples like keyboards, mice, microphones, and scanners. Conversely, output devices are how the computer sends processed information back to us, including monitors, printers, speakers, and projectors. Together, they form the bedrock of human-computer interaction, enabling the smooth, two-way communication that makes computers incredibly powerful and indispensable tools in our daily lives. Understanding this basic distinction is not just academic, it's a fundamental key to grasping how computers operate at a higher, more holistic level. Fantastic work today, everyone. You've successfully grasped how we interact with computers. Next time, on day 4, we're going to dive even deeper into the very brain of the computer system itself, the Central Processing Unit, or CPU. You'll learn what makes a computer fast, how it executes all those instructions you send it, and why it's the heart of every digital operation. Make sure you're ready, it's going to be a fascinating journey.